Hello there. So this is the Sovol SV08 that I just bought myself for Christmas, and it's kind of a unboxing, setup, and 3D print video. I didn't really give explanations through this video step by step because I saw there is a lot of videos out there already. I am actually late to this printer. A lot of people already bought and made videos about this printer. Those videos did help me make this decision because I was very close to buying a Bamboo Lab A1. I wouldn't buy the P1P, it doesn't make sense to me. But the A1 kind of makes sense because I thought, without using those printers or this printer, I thought that it would be more reliable. And my last printer was actually a K1 Max. And won't go too much into the details. In short, got rid of it. It's gone out of my life, and I'm happy for it. It was a disaster, and I have been 3D printing for 5 years now, and I could troubleshoot that printer, and I did. I made lots of upgrades, and I have videos on that as well. But it just wasn't worth the trouble. So got rid of that one, and then I thought I want something much more reliable that just prints because I like to design functional things and print them. If it prints fast, like you think of an idea, in 20 minutes it's printed, much like this printer or the Bamboo Lab. They're high-speed printers with those accelerometers and leveraging the clipper and pressure advance features. So I wanted a printer like that and a reliable one at that. And then I was researching the Bamboo Lab A1, and I found that that can have problems too. It has some people have got into some troubleshooting steps, and because it's a closed environment, you're kind of restricted in that ecosystem. So I was like, okay, if I have Sovol F08, SV08, which is known to have some problems, it is not perfect, and I have Bamboo Lab A1, which is a closed system, I would rather have problems in an open system because then I can fix the problems, change the code in the Clipper, maybe even go to Clipper main, which, by the way, I haven't done yet. So we will talk about that a little bit right now. So, anyways, got this printer, and soon after I do the unboxing, you will see it started printing out of the box. Fantastic. I'm very happy with this. I did have to fix some problems. I will talk about that later in the video. So, a lot of feedback I have seen about this printer is that it takes an hour to set up and it's a little bit complicated. However, in my experience, and maybe that's just me because I have, used like over 30 different 3D printers. So I've assembled a lot of 3D printers. So I kind of get it. So I just knew that this four, corners, the ones with the stepper motors, will go in the four corners, and they're already labeled Z1, Z2, Z3. So it's basically Z1 matches with Z1. It's pretty straightforward. And so without even reading the instructions, I started putting those corners together, as you can see. And then the only reason I had to read the manual is to know which screw goes to which hole, essentially. That was the one that I had to find the manual for. And you will notice I will kind of go back and forth, pause the video and go back and check those screws and put them together. So yeah, putting this, four corners was pretty easy. I just started doing that without even flipping the pages. So that was obvious. Putting the gantry in the place was also very simple. Some of the screws were a little bit difficult to get to given the level at which the gantry was, but I kind of managed because I didn't want to turn on the printer without fully setting it up, so I did get to them in a little bit odd angles. It wasn't too much of a big deal. So yeah, basically put the four corners together, put the gantry in, put the top in, screw them based on the manual, plug in the display, plug all the wires. There is a lot of wire that you have to plug, that is another thing I had to see the manual for, because I just wanted to make sure I am not missing any connections, any wire connections, because that could lead to a disaster and break your printer, right? So I did that. The other thing I did after fully assembling the printer, which a lot of people have warned me in the past about this printer, that if you don't update the firmware, there might be a bug which will basically make the printer self-destruct, in the sense where the nozzle will just, crash into the bed and destroy it. So I didn't want that to happen, so I updated the firmware and made sure it it was leveling properly, the Z offset, it was working properly. Now that being said, once I so initially, once I set it up, made sure it's Z offsetting properly, did all the calibrations, as in, run the auto calibrations for the vibration and all that. So it did all that, and it started printing fantastic. You will see later in the video, it prints in both TPU. TPU, by the way, always printed very reliably. The only time I had a problem with TPU was when I had too much of an overhang, and obviously because it's a flexible filament, I was using Ninja Flex, which is, by the way, even more flexible than some of the other TPUs. That one overhang is a no up to a certain angle. It will a certain lower angle works, but some angles it will just start falling apart. So moderate overhang TPU works fantastic. Why? Because TPU can print in a bed temperature of essentially 65 degrees about, and that worked fine with the normal off-the-shelf Z offset, whatever worked, everything worked fine. Then I started printing PETG. Initially, PETG was also working fine for smaller parts. And that's what I have in this video, because this was the day one I set it up, print things. And as I was moving into more bigger parts that, spread across the bed and you have to level the bed more, I was having some really crazy issues. And I posted it on a post actually in Reddit, because I was very, what should I say, amused by the problem, which is it was having all sorts of problems. Like, not only there was the offset issue where the print was starting either too close to the bed or too high from the bed. And it was having layer issues. It was having some artifacts, random artifacts on the walls also. So a lot of issues, and adhesion issues. It was also peeling off the bed very easily. And all this was happening while I had PETG, the bed temperature 75. And that was my fault. I should have put the bed temperature for PETG to 85. I put it to 75, even though it was kind of sticking, it was not sticking well enough, and it was having many other issues. So as I was debugging those problems, what I did was I found in the Sovol Reddit page, there is a post that talks about how you can update the macro for start print and update the startup script essentially in Orca Slicer, and that will lead you to have Z offset tuning automatically happen before each and every print, and that will make it more reliable. I also edited the script a little bit so that the bed temperature is right to the target temperature sooner in the script, and it will do the Z offset while maintaining the temperature of your print, because the one that comes stock with the printer, the script that comes stock with the printer, is wrong in the sense that the Z offset macro, it sets the bed temperature always at 65, which if you think about it, if the bed temperature is, say you're printing it is in 85 degrees and you're doing the Z offset at 65 and the bed expands, so your Z offset is obviously wrong. So the script fixes that bug. I updated that fix. However, at 75 degrees, Z offset was going nuts. Like it was going all over the place, anywhere from minus zero point 0.4 to plus zero point 0.4. That's a huge difference. And then I changed the temperature to 85 degrees, and suddenly, like magic, all the problems were gone. Somehow at 85, the bed expanded to the right level in time for the Z offset to work. The Z offset happened, and it started printing, and every single print since then has been perfect. Like no bed adhesion issues. 85 degrees, it just gets the right Z offset. The first layer is always at 0.25 millimeters, and it's been perfect since. So yeah, the printer, as you can see, is set up here. I'm just loading the filament. About loading the filament over there, I was not exactly into this whole the PTFE tube going all the way from the sensor to the hot end. Eventually, what I did was I made it like I basically removed that coupling, the PTFE tube coupler, and cut the PTFE tube so that there is a short tube on the top of the hot end, and essentially a tube exiting from the filament sensor. That's it. And then in the middle, the filament is currently running free. So right now you see the video, I set it up as stock, as designed in stock. But eventually I changed to that open PTFE tube in the middle because that seemed to work better for TPU at least. And I can also, there is some PLA I work with, the glow in the dark PLA, which I've noticed that it doesn't work well with PTFE tube. It works better in a heated environment, which I will make future videos where I already have enclosed this printer, not in the traditional way. I didn't buy their kit to do the enclosure because I wanted to save money. I just essentially used scraps that I had around home to enclose the printer. But yeah, so far removing part of the PTFE tube and run the filament open work for me. Might not work for everyone. I get there could be issues with that as well, but that approach works for my needs at least. Keep in mind, most of the parts that I print, they're functional and they're typically lower in height. They're typically closer to the bed. The stuff that I print. So they're not really tall prints. So it's not like the gantry, raises up too high. Typically, I have all my prints have been within the first 200 millimeters. I have not gone past that yet for any of the parts. So going back to the setup, I set up this PTFE tube. For PETG, it worked fine, just as stock. My future plan is to move the sensor closer to the hot end. That way, when the print stops, it has a little bit less of a filament waste before I switch, right? That's kind of one of the things I'm thinking. The other idea I have, you will see in one of the later in this video, I have printed some parts using without using the cover of the hot end, which also has the cooling fan, but luckily there is also a cooling fan from the back of the hot end. So there is essentially two fans, even though the one on the enclosure here at the front is actually more powerful. But for TPU, I noticed you don't really need too much of cooling as long as you keep the speed low, which you have to kind of for TPU. Because of the flow rate, you cannot push TPU too fast. It just wouldn't work. So the volumetric flow rate, there is a bottleneck there. So I didn't think the cooling would be a problem, which you will see some of the prints later on in this video. TPU, it did fantastic. Yes, there is a little bit of stringing, which is acceptable. You just have to use a little bit of, blowtorch to, burn out the stringing, which you can do outside safely, so you don't have any toxic fumes in the house. So yeah, I sometimes print without the enclosure, the blue enclosure thing on the hot end, because that lets me see the print that's going on much more easily. The enclosure is kind of surrounds that entire area, so it's hard to see what's going on under the nozzle unless you see it really closely under that point. Yeah, this is where I'm kind of homing it and starting to test out the printer. But eventually, my plan is to design this hot end in a way that it is a little bit minimal. Uh, uh, I'm also not a big fan of the sensor they're using, the eddy current sensor they use to measure the Z offset. Uh, there is clearly some issues with that. Again, at 65 degrees for TPU and at 85 degrees for PETG, somehow it works perfectly. Um, I don't know what's the secret behind that situation, but clearly the Z probe that actually where the hot end touches physically the bed and measures where the bed is uh, feeling the pressure by using piezo sensors on the four corners of the bed. I personally feel that's superior to this sensor, the eddy current sensor. I could be wrong, but in my personal experience, the pressure sensor has never failed me. But I could be totally wrong there. So you can comment in the video why this eddy current sensor could be better than the piezo sensor, where it feels a touch of the hot end physically. Um, but yeah, I do plan on changing that eventually, uh, and then update Clipper to account for that. Yeah, this is where I had to raise the hot end a little bit to get the bed to the PI sheet to set properly. So yeah, it would probably be easier if I raise the nozzle a little bit more. But I think at this point I didn't even raise it. Yeah, I was just trying not to move the nozzle too much because I read a lot of horror stories where the nozzle crashes into the bed. So I was being very cautious so far. I like that milk crate look of the plastic base. It works. It's structurally very solid and it's not too heavy for a 350 millimeter cube build volume printer. It's not too heavy. It's easy to carry. It gets a little bit trickier once you put the enclosure in, but I'm a fan of the design so far. So yeah, we can see the printer is doing a bed leveling, the mesh leveling. It moves very fast. The acceleration on this printer is faster than Bamboo Lab actually. You can probably see that in the specs, but I personally experienced that it actually the speed mix it is faster. Like if you even if you're printing a part, you can produce similar quality with the Sovol SV08 compared to Bamboo Lab in some cases at least uh, in a faster speed. So very impressive machine, and obviously that's because it's a Voron clone. I mean, it's not using the most expensive hardware, but it's still the design is robust, and it has linear rails, solid linear rails, um, good belt. The quality, the build quality, yeah, I can complain. The frame, maybe there could have been some improvements to make it a little bit more rigid. I know why they didn't, because their game plan was, hey, when you put those metal enclosures that they sell, uh, that will introduce more rigidity to the frame. On my case, though, I didn't buy the metal enclosure kit. I just installed some plastic that I had lying around, and that's what I used for enclosure. Works great, but I'm guessing at a higher printing height. Again, I have only printed up to like 200 millimeters. Higher printing height, I am foreseeing there could be some issues with artifacts on the walls. But below 200, I haven't noticed anything. It's doing great. I did have to calibrate the pressure advance. You will see in Orca Slicer, the default pressure advance is just set to point, I think it's 0.02 if I'm not wrong. And that, you have to remember, is not the correct pressure advance for the filament you're using. I think it differs by filament. Again, I could be wrong. Please correct me if I'm wrong in any of these statements. But in my experience, I saw that it was printing like this print you will see right after the calibrations in this video. The prints, I did it without any calibration. So off the shelf, I just sliced it on Orca Slicer, not a pre-sliced files, mind you, just freshly sliced out of Orca Slicer. I printed some stuff because I didn't want to judge the printer by printing something pre-sliced, because they could be tuning that in the factory in whichever way they want. So I never print those files that they give in the pen drive or the USB drive they provide with the printer. I never use those. So slice them, and with the PETG filament, the white and the red filament, it worked great. And they were a little bit better filament I got. One was inland from Micro Center filament, and that worked fantastic. And then I got a cheaper G-Tech or something, some out of eBay, some another filament, which is not shown in this video because that was more recent since I made this video, and that did not work well at all. It was having booger problems and a lot of other issues that I also talked earlier in the video. So huge lot of problems with that PETG. Again, I don't think the issue was entirely for the PETG, because clearly I was using the wrong temperature and everything, and wrong pressure advance. But I'm just pointing out, for some filament, the pressure advance somehow didn't matter much. But for this one, it did matter more. So when I did the calibration of the pressure advance, which again, Orca Slicer comes with the script for that, which you can just run the script. It will tell you the number and everything. You see which one is best and select the pressure advance and plug it into your settings, right, in Orca. And once that was done, boom, it was perfect. So even the cheaper eBay sketchy PETG printed perfectly. There's a tiny little bit of stringing, but yeah, I have a feeling if I put that filament in a filament dryer, which I haven't done yet, it might even improve the print even further. But yeah, look at that tiny little boat over there. For that, there's that ship game where you try to hit the ship using coordinates. That one printed great. This is a toy train that I printed for some Christmas gifts, and these are the caboose that goes behind the train. Printed fantastic. This one actually printed without any calibration, but with calibration later, things get much better in other videos. Yeah, you will see there is a layer line. I think there was a little bit of layer line, and I don't think that's happening anymore since I did the Z offset calibration and everything. This is TPU. So right now you're seeing TPU being printed. The cool thing about TPU I learned recently, because before I used to print on glass, and this is it the first time? I think this is the first time I'm printing on a textured PI sheet. And then there I learned that if the sheet cools, you cannot peel off the TPU. I mean, you probably can, but you are definitely going to damage the sheet. So you have to heat up the sheet again, and then it peels off fairly easily. I think around 65 degrees it peels off fairly easily. So since I learned that, I have been trying to play with the bed temperature a little bit when it comes to TPU. This, mind you, this is not possible with PETG or PLA. But with TPU, what I tried is, what if I turn off the bed header completely? So first it starts printing at 65. Layer 2, turn off the bed heat completely. And then once the printing is done, I manually turn the bed heater on again and just peel off the print when it softens. I have tried doing that, and with prints that are lower in height, that worked. And I like that because TPU is a slower print, it takes many hours, and I was essentially hoping to save some electricity cost of print. So even if it runs for a day, I don't care because the bed heat is turned off, and at that point the printer is actually costing very little in electricity because it's just the hot end, which is a much smaller heater block. The main cost is the main power heater of the bed, and it's a big bed, and you cannot hit it partially. The whole thing heats up, and it worked. I don't know if I was risking the print at that point. I do know for taller prints, again, I have a future project I will show you a video of later. That didn't work so well for multiple reasons. It also had an overhang issue, but I did keep the heat on for the taller print. Just didn't want to risk that. But for this print, for example, it worked fine. This is back in PETG, by the way. This is a red PETG. Again, good quality from Inland Micro Center, worked fine. And there's the white one was also a good PETG. Did not have any issues without further calibration. This is all off the shelf. But obviously the print quality definitely improves with calibration, even with the better filaments. But yeah, going back to the TPU, just food for thought. I wouldn't recommend that playing with the temperature like that if you're printing something tall and you have high stakes. But for some flat print, like the one you saw earlier, which was essentially a base for something, and the reason I printed with TPU is because if the base is TPU rubber, it would have a better. I thought it would have more stability where the part is standing, and that worked well. There was some stringing, if you noticed in that video. I actually reduced the stringing since by obviously doing some calibrations with the pressure advance, the stringing gets reduced significantly. But also, the thing I tried to do is make it wipe on the wall, and also try to not cross wall. There is a setting where it avoids crossing walls. And essentially what that does is it travels along the walls. Now, in the older printers, you would never turn that on because that would increase the travel time so much because it's going around, along the lines of the walls. It would take forever for printing. But with these crazy high speeds the new printers have, it doesn't matter what direction or route it takes to travel. It will get there super fast, like because the travel speeds, you might reduce the print speed because of volumetric limitations, but there is absolutely no limit on travel speeds, right? Like you keep it on the top speed of the printer, which is like 700 millimeter per second and 20,000 millimeter per second square acceleration. At that point, it basically takes no time. It's negligible time that is added to your print. You can't even tell the difference. So if you run the traveling along the walls, you don't really get any string. Like if you see the slicer and you see the travel lines, they essentially disappear because they're all hiding within the walls. And that has been fantastic for reducing stringing both in TPU and PETG. It doesn't completely disappear. It will, even though it is pulling the string along the wall, obviously sometimes if there is too much string, it will show, but it significantly reduces.